In this video, we'll talk about representing bit patterns in hexadecimal notation. Computers represent and understand everything in the system in the form of bit patterns. Each bit pattern is a sequence of binary digits, or the so-called bits. Each bit can take either one of its possible two values. Typically, we are familiar with a bit taking either the value 0 or 1. Normally, computer programs will convert data into their binary representations, and it can convert them back to real-world meaning without human users needing to look at the strings in their binary forms. However, in some situations, such as when hacking a save file, or when optimizing how computer system utilizes memories, we might want to analyze these binary representations. Let's imagine that if a character is represented using 8 bits, this is how long the word love looks like. Obviously, we would love to have a more compact representation while it still straightforwardly reflects the underlying bits. We love to use the hexadecimal notation. A hexadecimal string is a sequence of hexadecimal digits. Let's call each hexadecimal digit in short as a hex digit. While a bit can take two values, a hex digit can take either one of 16 values. Typically, people use numbers 0 to 15. However, for the number with two digits to be nicely displayed in one digits, they are mapped to Latin alphabet, with 10 being an A, 11 being a B, 12 being a C, 13 being a D, 14 being an E, and finally 15 being an F. Since a hex digit can hold either one of 16 different values, a hex digit represents as many different values as what 4 bits can hold. Therefore, 4 bits are converted to one hex digit. If you are familiar with high school mathematics, you will find that converting between bit strings and hexadecimal strings is similar to converting numbers between their base 2 representation and base 16 representation. If we start with the bit string 1, 1, 0, 0, this is the decimal value of 12, which is the hex digit C. If you have a longer bit string, such as 1, 0, 0, 0, 1, 1, 0, 0, we split it into two sets of 4 binary digits. The first hex digit is then 8, and the other one is C. Now, let's revisit our love. First, we split the bit strings. Then, we compute each 4 bits into hex digit. So, for example, the first one here, this one is 2 raised to the power of 2, which is 4. This one is 2 raised to the power of 3 plus 2 raised to the power of 2, which is 8 plus 4. This is 12, which is actually the C hex digit. Then the next one, this is 2 square, it is 4. This one is all ones, so it is 15, which is an F. The next one, this is 2 square plus 1, which is 5. The next one, 0, 1, 1, 0, this is 2 square plus 2, this is 6. Then this one is again 2 square, it is 4. The last one, 0, 1, 0, 1, which is 2 square plus 1, which is 5. So we find that with hexadecimal notation, our love is a lot simpler to understand.